Hey everyone, how you doing? Well, in this video, we're continuing the triangle congruency. We're going to prove the isosceles triangle base angles theorem, and then its converse, so like the opposite direction. We're going to look at how to tell if two triangles are congruent using the congruency statements that we talked about last video, and then do a couple of proofs of triangle congruency. Okay, so we'll start. Make sure you have your guided notes if you're watching this video. Read these guided notes. We're going to start with the isosceles triangle base angles theorem.
Jessica, can you contact the main office?
Sorry.
Jessica, please
Seems to always happen,
huh?
huh?
Thank you.
So we need an isosceles triangle. Okay, and we're going to call it A, B, C. Let me get my statement and reason over here. Okay. So the triangle, or the base angles theorem, is just saying that if I have an isosceles triangle where the two congruent sides, the angles opposite of those two sides are also congruent. So basically, we're given that side AB is congruent to side CB, and we want to prove that angle A is congruent to angle C. Right? Well, so let's write down our given. So side AB is congruent to side CB, and that's given to us. First thing we're going to want to do is we're going to want to make a midpoint, okay, on the line AC, and call it point D. We're going to draw a line. We're going to draw a line straight down. Okay. So, D is a midpoint, and that's by construction. What we mean by construction is it means that we added on to the image that we already have, to the triangle we already have. Okay. Because of that, because D is a midpoint, side AD is congruent to side CD. And the reason for that is because of the definition of a midpoint. Right? So this side is congruent to this side. Okay. Now, it's kind of obvious, but the line that we just made from B to D is congruent to itself, right? It's like a number. A number is equal to itself. 5 is equal to 5, right? And we're going to state that. So line BD is congruent to line DB. I write it backwards like this to show it doesn't matter the direction you're looking at, that line is equal to itself. And this is called the reflexive property. Reflexive property. Okay. Now notice I have two triangles here, and I have side, 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 side. So triangle ABD is congruent to triangle CBD by side, side, side. And thus, angle A is congruent to angle C by CPCTC. Okay, CPCTC, little tongue twister there, is congruent parts of congruent triangles are congruent. Okay, you can see it's written down here at the bottom of the notes. Basically, that's what it's saying is if I have two triangles that are congruent, then everything about them is congruent. Even the angles, all the sides, everything is congruent, all the measures are equal. It's kind of common sense, but we still need to write it. Okay, and that's the proof of the isosceles triangle base angles theorem. Let's look at the converse now. So the converse, I have a triangle. These two angles are congruent, not the sides. Okay, the angles are congruent, so we're proving that the opposite sides are congruent. So I'm given that angle A is congruent to angle C, and I want to prove that side AB is congruent to side CB. Okay, so let's write down our given here. So angle A is congruent to angle C, and that is given. Now we're going to make an angle bisector. We're going to look at angle B, and we're going to make a line that bisects angle B. What a bisector is it cuts the angle exactly in half. Right? The prefix bi means two. Sector, it cuts it into two parts. Okay? So a bisector of angle B. So this angle here is congruent to this angle here because it's a bisector. And it's going to intersect on the other side at point D. Now we don't know if this is a midpoint. Okay? The last one we knew it was a midpoint because we created it that way. We didn't create a midpoint this time. We created a bisector. So our construction is line BD is a bisector, and that is by construction. Right? That's what we just constructed. And then because of the bisector, angle ABD is congruent to angle CBD, and that's because of the definition of a bisector. Kind of running out of marker here, huh? Once again, line BD is equal to itself. So line BD is congruent to line DB, and that's reflexive, right? It's congruent to itself. Well, notice I have two triangles. I have angle, angle, side, angle, angle, side. Well, that's one of our congruency statements. So triangle ABD is congruent to triangle CBD by angle, angle, side, and thus side AB is congruent to side CB by CPCTC, and we're done. And this marker is done. Okay, so those are the two isosceles triangle theorems. Not too bad. They're actually really easy. They're very, very similar. One just uses angles. The other one uses sides. Make sure you have those memorized, or be able to perform, or be able to use appropriate thought process to prove it by yourself, or memorize this, one or the other. So let's go to the second page here now. Oh man, this eraser is not looking good, huh? So number one, we need to determine if the two triangles are congruent. I'm just going to bring it close for you here. Okay, notice these two triangles, we have a side, an angle, and a side. So these two triangles are congruent by side, angle, side congruency. Okay, let's look at the second one. Well, this angle is congruent with this one. This angle is congruent with this one. And look, this side is congruent to itself by a reflexive property. So we have an angle, side, and an angle. So these two triangles are congruent by angle, side, angle. Number three, right here. We have two angles, right? Angle, angle, and then this side shares itself. So this side is equal to itself. So angle, angle, side. Number three, angle, angle, side is a congruency statement. So those triangles are congruent by angle, angle, side. Let's look at number four here. So number four, we have an angle, and then a side, and then a side. Okay, now remember, the angle, side, side, or side, side, angle, is not a congruency statement, right? If it spells a word you shouldn't say in my class, don't use it as a congruency statement. So here, we don't know if they're congruent. There's not enough information that's given. Let's look at number five. Okay, so here's number five. We have a side, and then this side is equal to itself. So side, side, side. Side, side, side is a congruency statement, so they are congruent. by side, side, side. Let's look at number 6. Well, we only have a side, side here, right? A side. But these are vertical angles, so we have a side angle or an angle side, but there's nothing else given. So because there's nothing else given, we don't know if they're congruent. There's not enough info. Not enough information. Okay? And there are those 6. Now we're going to put this stuff into play. We're going to prove that 2 triangles are congruent to each other. Okay, we've got about 3 of them to do here. So our first one here, we have this. We have this right here, that shape. And this is A, B, C, D. This is a right angle. This is a right angle. This side's congruent to itself, or this side. And then this side's congruent to itself. Then we have a statement. Reason. So what's given to us is just what's written there on our picture. So let's see. Angle ABC is congruent to angle DCB. That's given, right? They're both 90-degree angles. Side AC is congruent to side DB. That's given by those little notches there. Side BC is congruent to side CB. That is given, right? Reflexive property. Well, actually, it's not really given. It's reflexive property. Sorry. Reflexive property. Alrighty. Let's see here. We have side-side angle, but remember, we can't use side-side angle as a congruency statement. So what we can do, though, is because these are 90-degree angles, AB is perpendicular, or excuse me, yeah, AB and CD are perpendicular to BC. So AB, line AB, and line CD are perpendicular to BC. That's just by definition. Right, last year you talked about slope of lines. Okay, when the slope of a line is opposite reciprocal, they're perpendicular, and it creates a 90-degree angle. Okay, 90-degree angles are perpendicular. Because of that, we know that AB and CD are parallel. They're equidistant. So AB is parallel to CD because of perpendicular lines. So this line is parallel to this line. Now we know that because these are parallel, angle ACB, so this angle here, is congruent to angle DBC. And the reason for that is because these are alternate interior angles. Right? They're on opposite sides of a transversal inside the parallel lines. So this is alternate interior angles. Now we got something here. We got side angle side, which is a congruency statement. So triangle ABC is congruent to triangle DCB by side angle side, and we're done. Okay. Let's look at the next one. So let's see here. We got a line like this. Oops. This is a 90-degree angle right here. It's a right angle. So is here. And then we got a point here, which is B, and a triangle, and a triangle. This is A, C, D, E, and then these two lines are congruent. So here we got our statement, reason. Okay, so given B is a midpoint, that means CB and DB are congruent. Gotta make sure I'm still recording, yeah. All right, since this is a midpoint, this side's half, this side's half, so these are equal to each other. So we have side CB is congruent to side DB, and that is given. It's also given that angle ACB, or we can just say angle C here. Well, we'll want to say ACB. Angle ACB is congruent to angle EDB. All right, so ACB, this one, is congruent to EDB, this one. And that's given, right? They're both 90-degree angles. That's what's given to us. And then line AB is congruent to line EB. Right? These tick marks say that these lines are congruent, and that's given to us also. Now, we do have a side-side angle, but that's not a congruency statement. So we got to figure something out. Okay? We either got to figure out that these two sides are congruent, or these two angles, right? Or these two angles up here are congruent somehow, some way. Okay? Now, let's draw a line between A and E. We're going to draw that line right there. Okay? Now, this is an isosceles triangle, right? ABE is an isosceles triangle because of, by definition. Right, so I'm going to say that triangle ABE is isosceles by definition. Right, definition of isosceles triangle, two sides are congruent. Thus, this angle here and this angle here are congruent because of the base angles theorem. We just proved it, right? So let's see here. Angle, we'll go BAE is congruent, right? Angle BAE is congruent to angle BEA, by base angles theorem. Okay. Now, once again, these are perpendicular, right? That means that AE is parallel to CD. So line AE is parallel to line CD by perpendicular lines. So these are parallel. Since those are parallel, angle EAB is congruent to angle ABC, this one right here, because these are alternate interior angles. And similarly, this angle is congruent to this one down here because of alternate interior angles. So let's put that down here. Angle, what is it? EAB? EAB is congruent to angle CBA. And we're going to put these together. Angle AEB is congruent to angle DBE by alternate interior angles. Now we have side angle or side angle side. So triangle, what is it, ABC is congruent to triangle EBD by side angle side, and we're done. Okay, let's go on to this last one. Now this last one, it doesn't ask you to write a proof, it just explains why. If you want to write a proof, go ahead, but it just says explain, it doesn't say proof. So I'm going to write down the explanation here, or at least I'll tell you. So here we got a shoreline. We got, what's the guy's name? Thales. And we have the shore here. And we got a ship out here. It's a warship. Mine's not going to look like a warship. And Thales measures an angle to the ship and then down to the shore. And then he measures the same angle. Ooh, that's not the same angle. Okay. And this is PQT. All right. So it says in the figure below, shows how the Greek mathematician Thales determined the distance of the from the shore to enemy ships during a war. He sighted the ship from point P and then duplicated the angle QPT. So he knows that this angle here is congruent to this angle here. He duplicated the angle. Okay. And he knows this distance here because he used a sight, right? He sighted it. So he knows that this distance here is congruent to this distance here. Oh no, sorry. Wrong. I misread it. The shore is equal to itself, right? PQ is equal to itself by reflexive. And he knows that these two angles are right angles with the shoreline, right? He just dropped a perpendicular line to the shoreline. Okay, and he was able to find this distance here, right? This distance here by measuring out a triangle on the shore and then just measuring this distance because these are congruent. Why are they congruent? Well, they are congruent because angle TPQ or QPT, whichever one you want, is congruent to this angle that he cited. The shoreline is congruent to itself, and angle PQ boat is congruent to angle PQT because they're both 90-degree angles. So these triangles are equal to each other or congruent to each other by angle side angle. And since the triangles are congruent to each other, we know everything about them is congruent by CPCTC, meaning that this side has to be equal to this side. And so all Thales has to do is measure this side on the triangle on the shore, and he knows the how far the boat is from the shore. Okay, and that's how you would explain that. And that's it for the video. Nice and short, right? Once again, as always, where'd my pen? Oh, here it is. I'm always here for you. Let me know if there's anything I can do to help you out.